before we start talking. Before we start. Hey. Yeah, man, you go.
All right. Welcome, everyone. My name is Alyssa Haber with The Essence of Science.
My name is Misha.
And I'm Dr. Abbasi. Today, we do not have Amanda with us. We are going to talk about the alcohol, and she's going to enjoy
Experience it for us.
in Napa Valley, in our Essence Ranch in California. So, hi, Amanda.
Hi, Amanda.
Enjoy the alcohol while we talk about it.
Well, we talk about all the things that it can do to her.
Yes. Well, now this is specifically the science of alcohol. I think it truly warranted to do a podcast, essence of medicine alcohol and the essence of history alcohol. But today we are going to talk about the science of alcohol. So I think the most warranted question is, Misha, what's alcohol?
I think it's defined as something that contains ethanol.
Something that contains ethanol.
From 0 to 96% ethanol.
You are not, she said it very politically, a Minnesotan way. You are not entirely wrong.
Well, you guys are medical professionals. You guys know chemistry more than I do.
I say I took a lot of chemistry courses.
Ethanol.
It's been a while.
Yeah. Okay, well, I'm going to tell you all about the science of alcohol. But can you repeat your answer for one more time? Let's dissect your answer because you're not entirely wrong.
Something that contains 0 to 96% of ethanol.
Okay. So what do you think what alcohol is on the chemical level?
Well, alcohol, I'm just going to say this is kind of funny. We always had this in our chemistry class. There was a big sign that says alcohol is a solution. And we always sat there and we had to have the debate on whether alcohol is a solution or a solvent. And we came down to, we could argue both ways. And Google has said both ways, but.
What is the difference between a solution and a solvent? Could you repeat? Educate me.
Well, I think Commons probably better at that scientific definition to me.
You're going to, actually, I think you're going to the other ways, but alcohol by definition is any chemical substance that has a O, oxygen and hydrogen connection. If you take like water is not alcohol because that OH, now water is one oxygen connected to two hydrogen. Now imagine you cut one of that hydrogen connected to any chemical organic compound. Then you create an alcohol. So by definition, it can be hundreds of thousands different kind of alcohol. And the idea of the alcohol, what makes it alcohol, the OH, is that part is soluble in water. That part can connect to water. The other chemical or organic compound of the alcohol can be anything, usually a hydrophobic solution. So meaning that alcohol is by definition something that has two halves. One half is a undefined organic material, which is a lipophil, meaning salt itself become a salt, either it attaches or solves like fats or anything non-water-based. And the other part is OH, which is by definition, because that OH is very similar to OH of water, can combine and practically be soluble in water.
Absolutely.
That the best thing you can do, take a glass or a bottle, make 1/3 water, make 1/3 fat, and then they're separate, right? And add another 1/3 alcohol and shake it, and then you will see that all of a sudden fat becomes soluble in water.
Would you like a shot of that?
No, I do not. I do not. Would be disgusting, I think. But
I think that would make for a great experiment, though.
Yeah.
every day, every time you have a dinner on alcohol, you do that experiment already, because that is what makes the fats better absorbable in your stomach, digestible. So they say, if you have a fatty food, have a little bit of a drink, and that makes it digested better. That is the mechanism of that. The alcohol part of it makes the fat that want to be like a small little vacuole come together like a droplet. It makes it better soluble, like a solvent is soluble in our stomach, which is mostly water-based, or most of our enzymes and so on, our life is water-based. The idea of alcohol is making anything fat that doesn't like to get close to water or our enzymes. It makes it soluble in a water-based environment. So now, by definition, we said that oxygen and hydrogen, OH, makes anything alcohol. That means we have hundreds of thousands of anything. Anything you add an OH to it, it becomes an alcohol. But most of the time when we talk about alcohol, we talk about a very specific alcohol, which is
ethanol.
Ethanol. What is the name come from? Ethanol. What is ethanol?
I don't know.
So let's go back to
like
organic chemistry.
It comes out to ethyl, which is isn't that an ethyl type of a group?
Let's talk about the IUPAC. IUPAC, do you know what IUPAC is? The international, how we call organic material. They have long, fancy names and so on. But what is a carbon atom that has 4 oxygen attached to it? Every time you fart, you produce that. Methane. Come on, guys. Give me something.
Methane.
What is if you have not 1 carbon atom, but 2 carbon atom? Ethane.
Ethanol.
What is if you have 3? Propane. Your propane tanks?
Sure.
3 carbon atom. That's what it is. Because, see, natural gas, you fart. Natural gas, ethane. It needs it's a 1 single atom. It needs a lot of pressure to make it liquid. But if you have 3 of that, it becomes easier compressible. That's why the tanks don't have ethanol. They have propane.
Okay.
Or propane. Okay. Mm-hmm. And then what about if you have 4? Now that you're doing it, butane. It's even become easier compressible. Then you can put it in a lighter and just a piece of plastic. So less pressure to compress it and so on. By the time you get to octane, 8, it becomes something. It becomes something that is already in the regular temperature liquid. Where do you put octane? What's the octane level of your gas you put in your
gasoline?
Gasoline, yeah. Octane, gasoline, octane. Octane, when you go to a gas station, it says octane of this is this, or 95 and so on. Mm-hmm. That is to what percentage it has 8 carbon atom in it. Okay, so
this makes me feel so dumb.
No.
I'm allowed to say that I made it 25 years of my life without understanding. I mean, I understood the percentage when it tells me, 10% of ethanol, and you just kind of nod your head and go with what's cheapest.
Yeah.
But it's really kind of interesting to actually
know. Now, if we go higher up, then we get to higher numbers, and then becomes like a gasoline, and then kerosene, and so on and so forth. But let's go back. You can attach an OH to any of them and make them an alcohol, like propanol. Like rubbing alcohol is what? Propanol.
Yeah.
It's propanol. It is not a different ethanol, form. Not 2.
It's 3.
No, propan is 3.
Oh.
Butanol would be the
Butane,
which is a 4,
4.
has one. Phenol alcohol. Have you heard
Phenol,
of?
I've heard of that.
Yeah, it is
No,
a ring. Phenol is a ring.
It's the perfect.
Yeah, the six-sided ring. Yeah.
Yep.
And you attach the OH to that phenol. So let's go back to ethanol.
Okay.
Because I think everybody want to know about alcohol, right?
Yeah, like the general definition for alcohol.
So now we covered what actually a definition of an alcohol is. We cannot talk about science of alcohol without talking a little, just a nudge about history of alcohol. No,
we love history.
When I was driving here, we talked about what do we do today. I was so happy you said, let's do science of alcohol.
Why am I not surprised?
because it is hard to be a doctor and not know a lot about alcohol. So thank you for choosing this.
The good, the bad, and the ugly of alcohol, right?
Let's talk first about the good of the alcohol, okay? And we have to talk just a touch about the history of alcohol. When did the mammals discover alcohol?
When they have too much fruit and they ferment it.
They still do. There are some chimpanzees in Africa. They literally, when they have the plums, they fall on the ground. When the plums are ripe, they fall on the ground.
Mm-hmm.
They put a group of chimpanzees that guard it for a week. So no other chimpanzee comes and eats it until it's fermented, then they have a feast. But originally, imagine it's in savanna, there's plenty. But you have this fruit that has sugar, and then all of a sudden it turns into something else that has an odor through this conversion. All of a sudden it is an additional source of food. Surprisingly, doesn't go bad too fast. When it has a certain amount of alcohol, alcohol actually acts like a preservative. So that is the part that we have to talk a little about the history of alcohol. Now, very, very long time ago, people noticed that anything that you get it fermented, anything that has sugar that gets fermented becomes more durable. It doesn't spoil so fast. And that was a big deal. In the time, we didn't have refrigeration and other preservatives. For a very, very long time, alcohol was our only preservatives. As a matter of fact, it was to a point, and again, I'm not going to go in detail of that, it was to a point that most of the Navy empires, like Dutch, Portuguese,
European type countries,
England,
Spain,
it was so important that the alcohol, whenever they went, it was their currency. They would pay the soldiers and people. It was actually because why would alcohol be a currency? They weren't all drunk. But why would you think alcohol was the currency?
Because of how valuable it was.
But what made alcohol valuable? So valuable, life-depending valuable. You're in a ship, and what is the most important thing you need in a ship in the ocean?
Water and food.
Water.
Hygiene.
Water. You need water.
Mm-hmm.
Do you think they just opened the faucet and got this beautiful, nice water?
Drank it straight from the ocean.
No, you cannot.
Just kidding. I'm just
right?
You get a dirty well and bring as much water you can to the ship with all the bacteria.
Put them in a barrel.
In the barrels, yeah. They would, in a big barrel, they would have a formula. They put a bucket of alcohol in a barrel of water, and now they wouldn't get sick of it. They wouldn't die of it. Preservative.
Interesting.
Necessity for life. And how does alcohol work there? It should be clear. You know, what do they say? If you have a wound and so on, put alcohol on it, you already feel it. You know, if you have a wound, you put alcohol on it, you feel that it's killing.
It stings.
It stings because it's killing cells that it's directly attached in higher concentration. Even in much, much lower concentration, like a barrel, a real general barrel, you put a bucket of alcohol, then that water becomes healthy and drinkable. At least you don't die of it. It won't taste good. It still tastes probably bad, but it is necessity in the long voyage that you have. So that is why alcohol is so important and become necessity of these voyages and something that you could pay people with.
I have a
commodity of life.
Yeah, me too. You go first.
A question, kind of a comment. A lot of what we learned today from the past, you know, were done by past mistakes, we would say. Since we know alcohol, if you dump it into water, you know, it kills them and makes them not sick. I am curious as to how many people it took to consume the alcohol to try and kill the bacteria or make them not sick before they figured out that that's not quite how that works.
Well, my question is kind of like, how does alcohol kill bacteria?
Great question.
All of that comes back down to what alcohol is.
Yeah.
What is alcohol? It's like a soap. It's a very basic soap, right? But it's more than that. It has a soap that is very short. Now, what is life made of?
Cells.
Cells. Let's stay with cells. What is a cell?
The basic building block.
No, what is the basic principle of a cell?
Like nucleus
DNA,
and the membrane.
But membrane, let's talk about the membrane. What is a cell membrane made of?
Starts with the C.
You can do it even without life. You get, most of cell membrane is made of a long chain triglycerides.
Sure.
That is, so triglyceride, and they have 3 chain or sometimes 2 chain, but mostly 3 chain of fat, long fat. And then on top of that, you have glycol. What is a glycol? It doesn't have 1 OH, it has 3 OH. Glycol is a propane that has, instead of 1 OH, it has 3 OH. What does it make it? That one side is very, very long chain, three long chain, fatty acids. So they are very, very fat soluble. The other side is very, very water soluble. If you just take triglycerides, which is a long chain of fat with alcohol on the other side, you just mix them, put them in a mixer, automatically you create macroscopic vesicles, macroscopic vacuoles. It's like a, what is a bubble? What is it when you go in a soap bubble? Did you know soap bubble is the thinnest things a human can produce, membrane that a human can produce already, but it's a 1 layer, actually 2 layer of soap on both sides, that this fat soluble part, they get like fingers, they get together. On the other side, they are the water soluble, but this is so stable that this macroscopic membrane can have this huge volume and still stable. That is unbelievable. If you look at the physics of a bubble, it's unbelievable. Now, triglycerides are much more stable because those fatty part in the soap, the fatty part is let's go back to soap. What is soap?
Saponification.
The soap is just, you take the glyceride out of, anybody did go to pay attention in the organic chemistry? So, a soap, you get the triglyceride, you get the glycol away from that, you create glycerin of it, which you use for lotions and so on. The fat part of it, you attach hydroxide to that. So you make from 1 triglyceride, glycol, and 3 soap molecule, which has a long fat molecule and a short hydroxide molecule that can solve, like the like the alcohol. It can solve.
It would have to be lipophilic, that seems.
Lipophilic and hydrophilic. So sorry for the nerdy stuff. This is the essence of science. Okay, so now let's go back to that. If all our cells are made of that and you throw in a bunch of alcohol there, you're destabilizing
the membranes.
The membrane. No membrane, no life.
That sounds terrible.
Well, it's good for us sometimes because then the bacteria die in that. And practically that makes cleans up practically whatever solution, whatever water you put there. Now, you ask a question, how long did it take us to understand that? In Middle Age, people of value would not drink water because water would make you sick and you would make you die. Even children, they would put a little beer or wine, mix it with water, then it would be safer to drink it. So we found out long time ago, water, not good. Wine, great. Beer, great. Almost in every culture, we noticed that we can ferment grains, we can make it beer, or any fruit with high sugar value, turn it into wine. And drinking that was much safer than drinking water. It has been for thousands of years that drinking beer and wine would be healthier than drinking water.
And I don't think they'd be entirely wrong by saying that either.
No, we changed the equation by having
back in the day
clean water.
Yeah, but I heard that alcohol dehydrates you. How do people cope with that?
Well, we will come back to that. Why alcohol dehydrates you, and there is a truth into that. But let's go back that now alcohol was a commodity because it would make water drinkable for a long time. It was better to drink wine, and if you didn't have enough of it, you have to just dilute it. And they didn't want their children to be drunk, so they diluted. But people of mean did not drink water because water would be unhealthy. Let's come back to that. Now you have this alcohol that obviously we noticed that it has different effect on us as well. It doesn't just make water drinkable. At a certain point, they noticed they feel just much better. The sailor drink much better. Then they wanted to drink the alcohol, not the alcohol in water. They wanted to drink the alcohol.
Drink it straight.
Drink it straight. Already the Roman, again, we cannot talk about the science of alcohol without talking a little about the history of alcohol. In every society that exists on the planet, alcohol was discovered, not alcohol. The fermentation was discovered and what was put to use. Whereas the first place in the whole earth, we have evidence that they fermented and created alcoholic beverages.
Greece.
I'd say the Roman Empire.
Oh no, long before that. Long before they existed.
China?
Yes.
Oh. Come on, Nisha.
In the Yellow River area, they found these pots and they analyzed that. It had some sugary wine, the alcohol, honey combination. And we have evidence from those potteries that was made truly for that the residue of that showed that so already 8,000 years ago, the Chinese had the first wine. That is the evidence we have. And then obviously it was used as well for ritualistic things.
Yeah, because food is like so scarce and you just put food inside and you're basically wasting like food to make this kind of drink, right?
No, but even more than that, yes, it is. But it is make the food actually preservable. But alcohol has a lot of calories itself.
Lots of sugar and carbs.
No, alcohol itself, gram by gram, has more calories than sugar. So
wow,
this is essence of science. So let's talk about how do we make alcohol? Because then it makes sense why gram by gram alcohol has more calories than the sugar. What is the sugar? What is sugar?
Fructose.
Glucose.
Fructose is one kind of monosaccharide.
Oh, monosaccharide.
Sure. Okay, sugar are compounds that have connected together and have multiple OH, but in a different combination that it doesn't. It is a kind of alcohol, but in a very specific configuration. And it is the base currency of life.
Wait, sugar is alcohol?
Sugar is alcohol in a way, yeah, but in a different configuration.
Okay.
That it's not a regular alcohol, like glycol is an alcohol, but it has 3 lines, but regular alcohol, they have only one OH. But sugar have multiple OH attached to that, and it is a 6-ring carbon ring.
Phenol.
Well, not like phenol. Phenol is a complete ring of carbon atom connected together.
Sure, organic.
But sugar, it doesn't completely connect together like a phenol. Okay, let's do the organic chemistry another time, but let's concentrate on, so sugar, sun makes sugar. Sugar, plants, they connect them together, they build their walls like a wood. This is sugar. Yes. Did you know that cellulose is a kind of sugar that we cannot break down? Some animals, they symbiote with bacteria that break it down like cows, and then turn it into sugar and they eat it. They eat cellulose, like cotton is cellulose. So, but let's go back to that. At the end of the day, life is based on sugar, water and sugar. So sugar is the energy. You take the sun, turn it in sugar, and then you burn the sugar in a biological way and create energy. I'm not going to go back how energy is, managed in our body. We
don't have time for that.
But when so just imagine when we get from sugar and we have these chains of sugar, we call them
monosaccharides.
Monosaccharide is one of them.
Right. It's polysaccharides or
polysaccharides are many of them, and disaccharides are 2 of them. Like regular sugar, saccharose is the 2 of them together make sugar. Like the glucose is actually not as sweet as disaccharide, but that is what we start. We break everything, first make it to glucose or monosaccharide, and then we break down monosaccharide the entire life, breaks the monosaccharides, makes the glucose to energy. What is this cascade called? There are 2 steps into that. The first step is making the glucose to what?
Alcohol?
Alcohol is the between step.
That's the between.
Glucose becomes vinegar, acetal vinegar. What's in vinegar?
I don't like vinegar. I stay away from vinegar.
So sugar, there is a non-aerobic or anaerobic path that makes the sugar to alcohol.
The fermentation process.
Then aldehyde, then acetyl
acetic acid.
Acetic acid, which is vinegar. So glucose, 6 carbon atom. It breaks down in 3, but that is very short. Right, all of a sudden, there's 2 CO2 goes away. So 6 become only 2 CO2 goes away, 4 left. 1 glucose becomes 2 alcohol.
Okay.
The ethanol becomes ethylaldehyde. Ethylaldehyde becomes
acetic acid.
Acetic acid.
Vinegar.
Vinegar. And then the acetic acid is fed to a very specific cycle in our mitochondria to create ATP. What is it called?
Is it the Krebs cycle?
Krebs cycle. Excellent. It's interesting. The plant does just the opposite. The backward makes water and CO2 to sugar. The mitochondria turn it back in. Now, let's not talk about the Krebs cycle.
Thank goodness.
Talk about I know. I love that.
I have PTSD from the Krebs cycle.
Everybody has it. Now, let's talk about again, sorry guys for the nerdy stuff. This is the science of alcohol, not the history of alcohol, not the medicine. This is the science of alcohol, so bear with me. So we feed sugar, we get acetyl acid or
acetic acid vinegar
out. Between those two, there are two steps, alcohol and aldehyde. Now, the idea is here, create a method that you stop at alcohol. You can try many, many things. Bacteria are very, very robust there, meaning that they get the glucose, they turn it into alcohol, then aldehyde, then vinegar, and then they eat the vinegar and you're done. So you don't get anything out of that, okay?
Okay.
But there's kind of yeast, specialized yeast, that we found out it turns the sugar to alcohol. Once the percentage of the alcohol goes above 10, 12, 13, they die. Then it stops. The process stops right there.
Huh.
That is the kind of fermentation we want. And we figured that long time ago how to get rid of everything else, just to have those yeast in place. Now, if you do it in nature, literally everything gets mixed. You cannot really do that. But what we do, we sterilize it and we give only that yeast that stopped there. You had a question about the moonshine. Why is it dangerous?
Because you can't control what bacteria is in there. You can't disinfect it very well.
You do a lot of different things, including, imagine you put the fruits or whatever grain you have, and you go through that process, and you have good bacteria that makes first you have to break it mechanically or chemically. You make the starch to glucose, and then your yeast take the glucose, make it to alcohol, but there are other things there. They make all the other things and produce a lot more chemical substance. One of those chemical substance is an alcohol, not with one OH, not with two carbon and one OH, but it's with one
methanol.
And methanol and ethanol has two carbon, methanol has one carbon. For our body, they look identical. Mm-hmm. But there's a problem there. Now, we cannot talk about this without talking a little about the medicine of alcohol. So, when we drink alcohol, an enzyme in our body takes the alcohol, make it to, it's called alcohol dehydrogenase, mm-hmm. make it to ethyl alcohol, okay? Ethyl alcohol, it becomes ethyl aldehyde, ethyl aldehyde. Mm-hmm. Now, that is the dangerous part because aldehyde is extremely toxic. As a matter of fact, we preserve our corpses with formaldehyde, mm-hmm. which is one carbon atom and aldehyde. Aldehyde has a different organization of the molecule on that. You don't go there. But then our enzyme is called aldehyde dehydrogenase, quickly turn that aldehyde to acetic acid, which is good for us. We can burn it. Mm-hmm. We get the sugar the same way. In our body, believe it or not, that is exactly the thing. The sugar become alcohol, become aldehyde, become acetyl acid, and then the Krebs cycle in the mitochondria turn it into energy. We do it the same way, but we never have that alcohol elevation in our body because that steps goes really fast, and that's a good thing. Mm-hmm. Now imagine you take the alcohol, too much of it, and then methyl alcohol. What happens? That our enzyme still turns it methanol to methyl aldehyde, but the other enzyme that makes the aldehyde dehydrogenase is not really good turning methyl aldehyde or
formaldehyde.
Formaldehyde. That's formaldehyde. That's methanol become formaldehyde. That enzyme is good to turning ethyl aldehyde mm-hmm. from the regular alcohol ethanol, but not good at turning
methanol.
So it accumulates. The same thing that you preserve your corpses with get produced in your body, and you can imagine that wreaks havoc on your body. You can go blind because our optic nerve is the one of the things that is extremely sensitive to formalin or metaldehyde.
Well, yeah, but it's not only moonshine. There are like counterfeit alcohol.
No, well, there are lots of other organic things that they affect our body in a very different way.
I actually had counterfeit alcohol before.
So tell me about what did you notice?
I think I was in high school. I was in China. The legal drinking age is 18 years old. So I was in a club, and the bartender just poured some thing in my shot glass, and I just had it. And the next morning, my head just exploding. And all my friends say, "Oh, you had fake alcohol." Like, I think that you just use methanol and water and some alcohol and some flavorful stuff.
No, it cannot be. A shot of methanol itself will kill you. It has some contamination of that. That the dosage that methanol can be toxic to you is so little. It's a contamination. It cannot be completely pure like a shot of methanol. You wouldn't be here for.
Well, yeah, I also hear about people drinking jet fuel because there's alcohol shortage.
Jet fuel is actually much less toxic. It's toxic, but much less toxic than same volume formaldehyde or methanol. Okay.
You'd be surprised the things that people drink to get alcohol. Hand sanitizer.
I'm not surprised what people do. I'm not surprised what people do. So, but let's go back to that, the science of alcohol. Now, we understand, we talked about what chemically alcohol is. We understand a little about the history, how we came to know it and why it was good at certain point, and how in our body it gets processed, and why methanol is toxic and ethanol is not, or ethanol is toxic as well, but at much, much higher dose. And let's talk about the effect of alcohol on our body.
Let's talk about it.
Now, what is the first thing you feel when you drink, have a shot of alcohol, or what's your alcohol of choice? What is your alcohol of choice?
I don't drink that much, but when I do, if it's wine or if I'm going to go out and be crazy, it's tequila.
Tequila, how many shots do you do?
Me at now or me at 21?
Yeah, what, you're 22 now? Come on.
25. Okay. I'm bad and old.
What's so tequila, how many shots?
3.
3. What about you?
Whiskey. I usually start with 4 shots before, like, it's a pre-game. 4 shots for pre-game.
Okay.
And then
you're unusual in that regard because most of the Asian genetic, their alcohol or aldehyde dehydrogenase is much less potent than the European alcohol dehydrogenase, meaning by nature, Asian can tolerate a lot less alcohol than the European. And as well, bad news for women, the female alcohol dehydrogenase and liver tolerate much less. So that alcohol can become toxic much, much faster because you accumulate more. Any after effect of the hangover is mostly the aldehyde effect, okay? Your body takes time to turn it over and get rid of it. And literally what happens is that if you have an enzyme that is more potent, that action goes faster. So, and this is different in cultures. It's just the way it is. The nature gave some people better alcohol dehydrogenase than the others. Having said that, that as well has something to do who can get addicted to that. We will come back to that in the essence of medicine, alcohol, but that is as well makes that, if you take a longer time to process that, you are more likely to get addicted to that because alcohol itself lasts in your body longer. So what is the alcohol effect? on our nervous system. Let's not talk about all of our body, but on our nervous system.
Nice little thing here for us whenever we're ready for it. This is
Wow.
the order that alcohol affects us.
Wow. Let's start with, what do you feel when you had your 3 shots of alcohol?
The first thing I typically start to feel is like some sort of sensation, you know, like I start to either feel tingles a little, maybe bubbly in the lightheaded, like, you know, airy, almost dream-like is kind of the first
Like
feeling I have.
Like a
you know, like
whoa.
Like maybe that slow down a little bit. Happy.
Slow down. Slow down. You actually mentioned 3 major things: slow down, happy, dreamy, and
well, I would add to that by saying more like polarizing emotions. Like
sure.
It just kind of like amplifies your emotion, whether they're being sad or happy.
Right away after your 4 shots of pre-gaming, you get in your emotions, Misha?
Well, yeah, I'm not very good at drinking. But yeah, as you just said, maybe Asians are not as good at metabolizing alcohol as other races, but we do have this kind of like drinking power dynamic at play in our culture. But I think we can talk about it in the history of alcohol.
Yeah, we should definitely. That's a good topic. I get tired, but once I drink more, I pass that tired stage, then I get the euphoria, happiness, and so on, and all the other sensations and so on. But that's why I drink barely, you know, a glass of wine, and then I'm done. I mean, most of the time, I don't even finish 1 glass of wine. So I'm just a very cheap date. But how does it work though in our brain on the molecular level?
It had something to do with the neurotransmitters.
Lots of different
in the
things,
brain.
but no, not neurotransmitter. This is at the cellular receptor level.
Sure.
But more or less, let's just condense it down. We can go days talk about that,
sure.
but let's condense it to 3 pathways. You know GABA?
GABA, yeah.
What is GABA? It sedates you. It reduces
the inhibitory system.
It's an inhibitory system that makes your neurons be less susceptible to pass a signal.
Sure. Because we hear
glutamine. What is it? Glutamine. It's excitatory.
Yeah, it's the inhibitory and excitatory.
Glutamine is excitatory, meaning that it makes it more likely to pass a signal. And then we have the dopaminergic effect. So alcohol has actually increased the effect of the GABA receptor and decreases the effect of the glutamine receptor. So it has a general depression on our brain. General depression. Wait, we are not done yet. When you have a general depression on all your brain, what is the biggest part of the brain?
Your cerebrum.
Cerebrum, where the human, the us, the we exist. What is the biggest part of our cerebrum? Frontal horn. What is the frontal horn for?
A lot of things: your personality, your speech, your understanding, your processing, your emotions,
all your reaction, a lot of things, but all your social reaction, all your everything. Everybody taught you what to do, how you behave, and how not to behave is in your frontal brain.
Yep.
Everything society taught you how to be is in your frontal brain.
Seems pretty important.
Well, it is important. Following the laws, not going and hitting on people.
Wearing clothes in negative-degree weather.
Like that, and so on. All of that, like norms of your society reside in your frontal brain.
Do you ever remove it? Do people
Have
ever
remove it? Have you heard of lobotomies?
Definitely.
Yeah, right?
Alcohol is a temporary lobotomy. That's what it is. Alcohol is a temporary lobotomy. Practically, by suppressing. Now, alcohol suppresses everything, but since biggest part of your brain is your cerebrum, and biggest part of the cerebrum is your frontal lobes, it suppresses everything equally. But since the effect of the frontal horn is the biggest,
we notice it more.
We notice it more. You become all of a sudden you are scared to go and hit on somebody in a bar. You have three things and you don't care anymore. Okay, it suppresses your social norm to a point that the other areas, even though they're all suppressed, they become more prominent.
They call it liquid confidence for a reason.
That's exactly how it works. But it suppresses everything. It has a general effect on all our brain. And then there is another part that if you suppress everything else, it's suppressed as well. But imagine you have the big boys and little boys, and you suppress everybody to same percentage. The big boys are going to be suppressed more. The little guy become more equal to the others. That little guy called nucleus accumbens septi. It's in part of our brain, just in the middle, that all of a sudden say, hey, here I am. And I have lots of dopamine. And what does dopamine do?
Makes you happy.
Excited.
Makes you happy.
Bouncing.
That's why alcohol is that's how people get addicted to alcohol. Because all of a sudden they get this dopamine effect of the alcohol. And then this is just the acute alcohol, okay? Let's talk about the chronic alcohol problem, okay? So
without getting too much into medicine.
But that is easy, actually. So if we talked about that, it reduces the effect of the glutaminergic system receptors and increases the effect of the GABA receptors. And your brain says, you're depressed, but I don't want you to be depressed.
So it fires.
Brain actually counteract by creating more receptors or less receptor of one kind. So that says, okay, this is the new norm, but I cannot have you depressed. You have to be awake, otherwise you will be eaten. Okay, so you need, then it compensated the receptors to a point that now you need alcohol to be at that level of awakeness. Meaning that if you remove the alcohol, you become, how do people who are alcoholic, again, we come back in the science of in the essence of medicine, alcohol, but if you have to overcompensate for that, and now your glutaminergic, they don't work well, they are less effective, your body produces more of that. And the GABA is high up, your body reduces that. What that means that when you take the alcohol out, they become jittery, they are hyperactive. They literally, I took care of those patients.
I've seen
they jump up and down like unbelievable. That is, we had to actually restrain them in the bed, in the hospital bed. And I'm not kidding you. They would jump with the bed about 4 inches up in the air with the bed. Because that is how they were shaking. That was how they were shaking. It's because everything is hyper-excitable. Okay? They don't get those highs of the accumbens septi anymore, the dopaminergic surges anymore, but everything is excitable, and now your body has to down-regulate again when you go to a withdrawal. More of that in the essence of medicine, alcohol. But this is now, we are at the science of alcohol, how it reacts on our lots of different effects, but 3 systems: GABA, glutamine, and dopamine. Okay, well, everything else we are going to say here is going to be on the human part, on medicine side.
Absolutely. I think there's a lot of good topics we can get into on the medicine side of that.
Let's go back a little in the time. They notice alcohol is good, but the damn yeast built it only up to 13%. But we needed, this is concentrated gold. We needed more. How do we get more? Distill. Describe, what's distillation process?
Distill is all I know. That's all I know.
What is the distillation process? What does it look like practically?
I just know it has something to do with the heating up process to evaporate out.
You have some condensation.
Yeah, exactly. If we put it together, we got it.
Good. Yes, actually very true. Now, alcohol has a much lower temperature to boil than water. So if you start increasing the pressure, the first thing that evaporates is alcohol. So you increase it up just before to the boiling point of water, just before boiling point of water, which is 100 degrees centigrade. actually this alcoholic stuff start evaporating, and then they become gas, and then you put it in a coil, put the coil in the cold water, and then they condense, and then what you got is
alcohol.
Alcohol. Well, they do it these days we do it in 3 stages, because the yeast truly, they don't just produce alcohol, they produce other things. They have a pre, and then they have a main, and then they have a other thing that is water. So we control the temperature in that evaporate. The first thing to literally liquefy is our heavier stuff. With higher temperature, other stuff will evaporate, but it comes with higher temperature. So the first thing that condenses the higher temperature are acetone and other things.
Sure.
And lots of flavor things. Then the main part that they call it hard, I don't know why they call it hard, is actually ethanol.
Okay.
And then at the end, there are heavier substance and water. So what they do this literally distillation process, and then they add certain amount of first part, pre-acetone.
That would be the very strong
that
type
is for
alcohol.
flavor. And depending on how you do that, you have like whiskey or scotch alcohol, this is what you get, the spirit, and then you put it in barrels and other things that exchange flavor with the, like I think they char the oak barrel, and the first thing you get is like cherry or that bourbon, and then if you use that same barrel later in somewhere else, they use that and then send the barrel to Ireland and they make scotch of it, same barrel. So depending on how much other the material you put in, you get different kind of practically alcohol. But vodka is more or less, it's just a pure alcohol, more or less.
Tastes like it.
Very little other things, okay? But depending on what you have in that, you make different. And as well, those organic material in the pre-part that you produce has a lot to do with what you start with. You start with the wheat, with the fruit. Potato, you start with the fruit. Most of the fruits are mostly for wine.
Rice
as well. You can make wine or you can make liquor out of rice. But different kind of alcohol that we consume they are produced by different kind of starting point, because they add additional flavor in a different way. That distillation process.
Do you know this plant called sorghum?
No, I don't know that. What is it?
It's a plant.
Okay.
So Chinese make alcohol liquor with this.
Yeah, and that is every culture has created, like they even make alcohol from cactus, agave cactus.
You said you can make alcohol out of anything.
What is the alcohol that we make from agave cactus? You like it. You just told me you like
tequila.
it. Tequila.
Yes. I don't like any alcohol, if we're going to be honest. I tolerate sometimes.
So what else do we want to know about alcohol, science of alcohol? Otherwise, we can wrap it up. I think this is a little nerdy because it is science of alcohol, okay? I bet in our history of alcohol, it'll be much more interesting. We can talk about it a lot more.
Yeah, I can tell you about how we put snakes in alcohol.
Snakes? I want to know that now. So,
you do?
Yeah.
So you just put snakes in it because it preserves it. It doesn't go bad, and it has a snake flavor.
It is mostly, I think, psychological.
Yep. And sometimes the snake will stay in the alcohol and dormant for years and wake up again once you open the jar.
I do not believe that.
Well, someone was bit by a snake in the alcohol. It was very rare, but it happened once.
Well, I go and look it up. I think it is pretty, in anything above certain point, it's impossible to sustain any kind of life. And that is the basic of the biology. If you increase, even the yeast that produce the alcohol, they die at maximum 13.5%, 14%.
Alcohol.
They die. That is why alcohol is a preservative, that they can put a body or a heart in alcohol from 300 years ago still will be there because bacteria.
Yep, this is the snake wine.
Yeah, I see that, but that snake, I doubt it'll be alive.
Coming back to life.
It's coming back to life.
I had one question though before we wrapped up. As you mentioned that alcohol has a higher concentration of calorie, or when I was talking about carbs and sugar, and you said we get to that, and I really want to know what makes alcohol per gram, or what the correct term is.
So you remember that alcohol, sugar to be energy first have to go shed 2 carbon atom.
Yep.
And then become alcohol. And then goes that 2 sugar atom become acetylic acid, and then go to Krebs cycle.
Yep.
So by definition, sugar has 2 carbon atoms that are not going to be our energy for us. You already shed that.
Sure.
So imagine you have 100 grams of alcohol. You have to add 1/3 to that, like
for the sugar,
to become a sugar.
There. Yep.
So it's gram by gram alcohol, and most of the energy we make is from acetaldehyde, acetylic acid in the Krebs cycle. That's most of the energy we make. So you already got rid of those 2 carbon atoms that is not useful to become energy. So you concentrated that. So gram by gram, alcohol is has more energy than sugar. So if you want to lose weight, go slow.
These are not doctor recommendation diet tips.
No, don't drink alcohol. If you want to lose weight, don't drink alcohol.
Okay.
That is a good recommendation.
That I can agree with.
Yeah.
And I think that's about all we have. Any other comments from you guys?
Actually, I have one last question.
Yeah.
So you just mentioned vodka is kind of like pure alcohol, right?
More or less.
More or less. So what's the difference between rubbing alcohol that you use in medicine and vodka, and why you can't just drink rubbing alcohol?
We talked about that at first.
Oh.
You remember rubbing alcohol, propanol?
Oh, it was 3 carbon.
3 carbon.
Oh, okay.
It doesn't taste good. We just start throwing up right away if we drink that.
The smell alone.
Do you ever use ethanol in medicine?
Yes, we do.
Rubbing?
We used to use that. There is something called denatured alcohol. Do you know what that is? Because we know there are lots of people, if they get their hands on alcohol, pure alcohol, they're going to drink it. We add things to that doesn't matter how tough you are. You cannot drink it. It tastes such that, you just take a sip of it and you will throw up. Because your body says, this is not what I want to have. Denatured alcohol is often used in medicine and many other places because in many regards, it works like alcohol, has the same properties, but you cannot drink it.
So why don't
additional stuff to it?
So why don't you use vodka to disinfect patients?
You could, but then if you use vodka, well, first of all, now you open the can of vodka.
Well, we're already live, so we might as well.
Okay. So when you buy rubbing alcohol, in what concentration do they come?
90%.
That's the highest, 91%.
Yeah.
95%. You can get it as well, 95% and so on. What concentration is vodka?
40. Oh.
40.
Okay. That was pretty self-explanatory.
Yeah.
Like the concentration is not enough.
Yeah.
To kill everything.
Well, no, it is. Concentration is enough to kill things. That 40 is still a lot more than, but it doesn't evaporate fast enough because that's still 60% water. For many things, you want something, you clean it, and then it evaporates. As a matter of fact, many bacteria, they are not killed by the alcohol effect itself, but by the evaporation phase of that. But these days, we have much better disinfectant than alcohol. I mean, barely anybody uses alcohol except for surfaces and other things and so on. But you want something that evaporates faster. Vodka does not evaporate fast enough because it has lots of water in it.
Thank you. That's very useful. Learn something new.
Yeah. You can get it. And by the way, any alcohol that is consumable, they put a lot of tax on it right when it gets produced. So meaning that it would be economically a madness to use vodka for disinfection. It's too expensive. Like,
could you imagine COVID?
Yeah. So
with alcohol.
Now this is as well. This is yet another thing: the science of life, the economy of alcohol, which is huge. When they produce alcohol, right where it gets produced, right at that moment, they have to add something that before anybody can touch it, that it's not human consumable. If you don't do that, you don't have to do that. But then you have to pay a huge amount of tax. For that reason, that then you could mix it with anything and sell it to people. Mm. So I could buy a barrel of alcohol. Actually, I looked it up. A barrel of alcohol, the denatured alcohol. I was for production. We need alcohol. Some of our cleaning thing goes with alcohol. You could buy different kind of alcohol, like pure propanol, but I could buy ethanol alcohol. Would work the best as well the same way. A barrel of alcohol for $200. A barrel. It's a lot of alcohol. But try to buy a barrel of not denatured alcohol. It is like 20 times more expensive because that can be consumed by people for recreational reason. And it's nothing illegal about that, but it is just much, much more expensive. So it would be madness to use.
Like cause and demand. People drink it, you can.
No, I mean, and it is that too. Alcohol has a lot of industrial uses, but we have to have a way to separate that industrial uses, which now need to be cheap, from human consumable part, which is expensive. Okay? Okay. This was very alcoholic, but dry. Talk about the alcohol because it is a science of alcohol. But I hope you guys learned a lot of that.
I did.
I know, very interesting.
So can you sum up what you two learned? We'll start with you. What did you learn today that you didn't know before?
First of all, the names that change by adding number of carbon, and that alcohol has a more general definition.
Yeah.
Yeah, I mean, I definitely learned, the steps from how it got from alcohol to acetic acid, which I probably should have known, but sometimes you need those refreshers. And that was really interesting to me. And then I really liked the talk of the membrane, the molecular level of the cell, and how alcohol can make basically anything lipophilic, because it kind of makes me think, and when we get to the essence of medicine of alcohol, when we talk about how it's excreted through the liver, which is kind of our fat type organ as well. So you got me kind of excited about alcohol.
Do you know what I learned today?
What did you learn?
I learned it's a good thing listening and reading books, because all the knowledge I gave you today was the condense of 3 books I read in the last 4 years. I didn't keep everything from that books, but it was enough to impress you two.
You impress me every day.
Okay, well, if you want to impress people, read books. Listen to things that makes you more knowledgeable. And here, in essence, that is our goal, to make you a more knowledgeable person. Every time you listen to us, you're a smarter version of yourself. So for Essence, I'm Dr. Abbasi.
I'm Melissa Haber.
And I'm Misha.
And as Amanda would say, stay safe. Bye, Amanda.
Yeah, we should send this to her.
Yeah.